March 12, 1943. 31,000 feet above the Ruhr Valley. Flight Lieutenant David Perry's gloved hands gripped the control column as the radio crackled with words every photo-reconnaissance pilot dreaded. Bandits, 8 o'clock high. 2 Focke-Wulf 190 fighters had materialized from a cloud bank above, their radial engines hammering as they rolled into attack position. The altimeter showed maximum operational altitude. The throttles were already through the gate, coaxing every possible revolution from the twin Rolls-Royce Merlins. And the mathematics of survival were brutally simple. Those Fw-190s carried 4 20mm cannons and could hit 400 miles per hour in level flight. Perry's photo-reconnaissance Mosquito, stripped of every ounce of unnecessary weight to mount cameras instead of bombs, carried nothing but film, hope, and perhaps a 10-mile-per-hour advantage. Perhaps. Before we continue with this story of innovation born from desperation, take a moment to like this video and subscribe to the channel. We're uncovering the forgotten technical battles that decided the war's outcome, and your support helps us bring these stories to light. Drop a comment and let us know where you're watching from, whether it's Birmingham, Boston, or Brisbane. Now, back to March 1943, because what Perry did in the next 4 minutes would rewrite the tactical manual for every Mosquito crew operating over occupied Europe. Behind them, tracer rounds began stitching the air, bright lines of geometry that marked their probable death. The German pilots had the angle and the altitude. Physics was on their side. In a stern chase like this, the Fw-190's superior diving speed should close the distance within minutes. Perry could see it happening in real time, the dark crosses on enemy wings growing larger in his mirror. Standard evasion tactics weren't working. Gentle weaves to spoil the Germans' aim only bled off precious speed. The Mosquito was already at full combat power, engines screaming at revolutions that would require complete rebuilds if they survived the next 5 minutes. And then Perry made a decision that violated every instinct, every regulation, every published limitation in the pilot's notes. He shoved the control column forward with both hands and pointed the nose straight at the German earth. In that moment, as the altimeter began unwinding like a broken clock, he understood something the Luftwaffe never suspected, that this wooden aircraft could dive faster than anything in the sky. The crisis facing RAF photo-reconnaissance squadrons in early 1943 was one of simple, brutal arithmetic. Intelligence officers needed photographs of German industrial targets, factory layouts, railway marshalling yards, submarine pens, with detail sufficient to plan bombing raids. The Mosquito was the only aircraft that could penetrate deep into German airspace, take the pictures, and return home with acceptable loss rates. Acceptable, but climbing. Number 544. Squadron operating from RAF Benson had lost 3 aircraft in January alone. Number 540 Squadron flying from Leuchars lost 2 more in February. Each loss represented not just a crew and an aircraft, but intelligence gaps that meant targets not bombed, factories that continued producing, and a war that extended. The Focke-Wulf 190 had entered Luftwaffe service in summer 1941, and within weeks it shattered comfortable RAF assumptions about air superiority. The Spitfire Mark V, which had dominated the skies over Britain, suddenly found itself outclassed. The Fw-190 could outclimb it, outdive it, outroll it, and carried heavier armament. German pilots called it the Würger, the Shrike, the butcher bird that impaled its prey on thorns. For Mosquito crews, the Fw-190 represented something worse than a dangerous opponent. It was a persistent nightmare specifically suited to hunting them down. The German fighter's BMW radial engine produced 1,700 horsepower, pushing it to 408 miles per hour at 20,000 feet. More critically, it could maintain high speed at altitude, where the air was thin and engines gasped. Photo-reconnaissance Mosquitoes operated at 25 to 35,000 feet, and the Fw-190 could reach those heights and still fight effectively. The pilots who flew these machines weren't novices. By 1943, the Luftwaffe had assigned some of its most experienced pilots to Jagdstaffel units protecting critical industrial targets. These men had hundreds of combat hours. They knew the Mosquito's patterns, the high-altitude approaches, the the straight photographic runs that couldn't be interrupted without ruining the pictures, the preference for dawn or dusk missions when long shadows revealed ground details. The tactical problem was geometrical. A Mosquito on a photo run had to fly straight and level for perhaps 30 to 60 seconds while the cameras cycled through their exposures. During those seconds, it was predictable, targetable, and defenseless. German radar stations would detect the high-altitude intruder and scramble fighters with altitude advantage. The Fw-190s would climb above the Mosquito's patrol height, position themselves upsun where they were hardest to spot, then dive with accumulated energy and speed. Once that dive began, physics favored the pursuer. The Fw-190's metal construction and heavier wing loading meant it could build diving speed more rapidly than the lighter Mosquito. German pilots would typically open fire from 800 yards, closing to 400, close enough that even average shooting would connect. Standard escape procedures, aggressive weaving, rapid climbs, diving turns, worked against Messerschmitt 109s. The 109 was lighter, more maneuverable at high altitude, but it lacked the Fw-190's raw power and diving speed. Against the Focke-Wulf, standard evasion often just delayed the inevitable. The German fighter could match every turn, follow every climb, and eventually position itself for a killing burst. Mosquito losses to Fw-190s had been climbing steadily through late 1942 and early 1943. These weren't acceptable attrition rates. Each Mosquito represented thousands of engineering hours, and each crew had months of specialized training. More importantly, failed missions meant intelligence gaps, photographs not taken, targets not bombed, factories that continued producing. What saved David Perry that March morning wasn't superior technology or lucky positioning. It was knowledge gained through an unusual background. Perry's credentials included something most photo-reconnaissance pilots lacked. He'd spent 6 months at the Aircraft and Armament Experimental Establishment at Boscombe Down in 1941, testing modified Hurricanes and early Mosquito prototypes. He'd been the man who flew aircraft past their supposed limitations to discover where theory diverged from reality. Test pilots lived in the gap between what engineers calculated and what airframes could actually endure. That experience had taught him a crucial lesson. The published never-exceed speeds were conservative estimates padded with safety margins for average pilots in average conditions. The Mosquito pilot's notes listed a maximum diving speed of 415 miles per hour. Perry had personally exceeded that by 30 miles per hour during a test flight, and the aircraft had merely shuddered, not disintegrated. The wings had flexed alarmingly. The control column had fought his grip. But everything had held together. More importantly, the rate of acceleration had been extraordinary. The Mosquito had gone from 380 to 445 miles per hour in less than 20 seconds of near vertical descent. Now at 31,000 feet with Fw-190s closing from above, that test pilot instinct overrode survival instinct. The inner voice that said, "Don't point at the ground," was silenced by the analytical part of his brain that calculated terminal velocity, wing loading, and structural stress margins. The Mosquito's wooden wings wouldn't fold like metal. They'd flex first, give warning. The smooth plywood skin would slice through air more efficiently than the Germans' riveted metal at extreme speeds. The light tail section meant the aircraft wouldn't become uncontrollably nose-heavy. "Hang on," Perry said, and shoved the control column forward. The Mosquito's nose dropped through the horizon like a stone released from a bridge. The altimeter became a blur of unwinding numbers. 30,000 feet, 28,000. The Merlin engines screamed as the propellers suddenly unloaded, over-revving into the red sectors. Perry pulled the throttles back to idle. He needed speed from gravity now, not power. The airspeed indicator needle swung past 400 miles per hour and kept climbing. Behind them, the Fw-190s followed. German pilots were trained for aggressive diving attacks. They rolled inverted and pulled through, pointing their noses downward, confident in their aircraft's superior diving characteristics. The gap should have closed rapidly. The heavier German fighters should have caught the fleeing Mosquito within seconds. 25,000 feet. The Mosquito was accelerating faster than Perry had ever experienced. The airframe began vibrating. Not the catastrophic flutter that preceded structural failure, but a steady, almost harmonic tremor. The wooden wings were flexing exactly as they were designed to, absorbing the aerodynamic loads. 430 miles per hour. 450. The control column grew heavier in his hands as air pressure increased against the control surfaces. Sergeant Jeffrey Morris, Perry's navigator, was silent in the nose, watching the altimeter unwind and the airspeed climb into territories that simply didn't exist in any manual. The mathematics of their dive were terrifying. They were falling nearly 6,000 feet per minute, accelerating toward the Earth at angles that seemed suicidal. But something unexpected was happening behind them. The Fw-190s were falling behind. Not slowly, not gradually, but dramatically. Perry risked a glance in the mirror and saw the German fighters still diving, still committed to the pursuit. But the distance between them was opening like a wound. 20,000 feet now, and the Mosquito's airspeed indicator touched 470 miles per hour. The Germans were perhaps half a mile behind, and the gap was widening with every second. The physics at work were counterintuitive, almost paradoxical. In level flight, the heavier Fw-190 with its greater wing loading should have held every advantage. But in a near-vertical dive, the equations changed completely. Terminal velocity, the maximum speed an object could achieve falling through air, wasn't determined by weight alone. It was a balance between gravitational acceleration and aerodynamic drag. The Mosquito's extraordinarily clean airframe gave it a terminal velocity that exceeded the German fighters by a margin nobody had calculated. Drag increased with the square of velocity. At 300 miles per hour, a rivet head created negligible resistance. At 500 miles per hour, that same rivet created 4 times the drag, multiplied across thousands of fasteners covering the Fw-190's fuselage and wings. The German fighter's metal skin, built for strength and ease of manufacture, was covered in these tiny imperfections. The Mosquito's sanded plywood, doped smooth and polished by ground crews who understood that surface finish meant survival, was aerodynamically superior. The Fw-190's radial engine, magnificent at generating power, created enormous frontal drag. The wide cowling necessary to cool the air-cooled cylinders acted like a barn door at extreme speeds. The Mosquito's inline merlins buried in streamlined nacelles presented far less resistance. Every design choice de Havilland's team had made for efficiency at cruise speed was now paying dividends in a regime they'd never anticipated. 18,000 feet, 485 miles per hour. The wings were flexing visibly, bending upward in a curve that would have snapped metal spars. The wooden structure absorbed the loads, distributed the stress through the laminated construction, gave warnings through vibration rather than catastrophic failure. Control effectiveness was changing too. At these speeds, the control surfaces became massively powerful. The slightest movement of the control column would generate enormous forces. Perry's arms ached from holding the aircraft steady, fighting the tendency to over-control. Behind them, the Fw-190 pilots were experiencing something entirely outside their training. Their aircraft were shaking violently. The controls were stiffening dangerously, and the Mosquito ahead was simply vanishing into the distance. German fighter tactics assumed their diving speed superiority. They'd built careers on running down bombers from above. This shouldn't be possible, but it was happening. 15,000 feet now, and Perry began the recovery. Gently, infinitely gently, he applied back pressure to the control column. The nose came up grudgingly, reluctantly. The G-forces built rapidly, 2 Gs, 3 Gs, 4. The wooden wings bent downward now under the load. Morris's vision grayed at the edges as the G-forces compressed his body into the seat. 10,000 feet, and the Mosquito was finally level. Engines windmilling at idle. Airspeed bleeding off to something approaching normal. 400 miles per hour, 380, 350. Perry looked back. The sky behind them was empty. The Fw-190s had given up the chase somewhere around 12,000 feet, breaking off to conserve fuel and altitude. They'd been outrun comprehensively, impossibly, by an aircraft made primarily of wood and glue. The radio remained silent. No more bandit warnings, no further threats. Just the steady drone of the Merlins as Perry advanced the throttles and began the long climb back to cruise altitude. "We shouldn't be alive," Morris said finally, his voice shaky with adrenaline. "That shouldn't have worked." "But it did," Perry replied. His hands were trembling slightly now that the immediate danger had passed. The physical aftermath of extreme stress, the body finally acknowledging what the mind had suppressed. They dived from 31,000 feet to 9,000 in less than 4 minutes, reached speeds that would require explaining to the ground crew why the airspeed indicator might need recalibration. But they were alive. And the film magazines in the nose contained photographs of the Ruhr that intelligence officers desperately needed. When they landed at RAF Benson 3 hours later, Perry filed a standard mission report, but he added an unusual appendix detailing the encounter and the escape maneuver. He described the speeds achieved, the control forces encountered, the structural behavior of the airframe. He noted the precise altitude bands where the Mosquito's acceleration had exceeded the pursuing fighters. Most importantly, he documented the outcome: successful evasion from a tactically superior enemy through extreme diving. That report reached Wing Commander Robert Oakley, who commanded No. 544 Squadron. Oakley had lost 3 crews in 6 weeks. He was desperate for anything that might improve survival odds. Perry's report described something that violated every instinct about wooden aircraft and safe flying. But it also described something undeniable. A crew that should have died had instead returned with mission-critical photographs. Within a week, Oakley arranged for Perry to demonstrate the technique to other squadron pilots. On February 26th, using a training Mosquito over the relatively safe skies of Oxfordshire, Perry took 3 different pilots up as observers. He climbed to 25,000 feet, then executed the dive, accelerating past 460 miles per hour, pulling out at 8,000 feet. Each pilot felt the forces involved, saw the wings flex, experienced the counterintuitive reality that the Mosquito could survive and even thrive in flight regimes that seemed suicidal. The technique gained a nickname almost immediately: the power dive, though it involved throttling back rather than adding power. Some pilots called it the crazy dive, acknowledging its apparent insanity. Flight Lieutenant Robert Wilson, who flew his first operational mission using the technique on March 4th, described it more bluntly. "You dive like you're trying to auger into Germany. You accelerate until you're certain the wings will depart. Then you accelerate a bit more." Air Vice Marshal Donald Stevenson, commanding RAF Benson and overseeing photo-reconnaissance operations, initially refused to authorize formal training in the technique. His memorandum to Oakley, dated March 8, 1943, was blunt. "We cannot instruct pilots to exceed aircraft limitations as standard procedure. The technique you describe may have worked once under specific conditions, but we cannot build doctrine around what amounts to structural gambling." But losses continued. No. 544 Squadron lost another aircraft on March 12th, shot down by Fw-190s over Wilhelmshaven. No. 540 Squadron operating from Leukars lost a crew over Bremen on the 16th. These weren't acceptable casualties. Each loss represented intelligence not gathered, targets not photographed, missions failed. Oakley responded to Stevenson with operational data. He documented that 5 crews had now used the extreme dive technique successfully. Not one aircraft attempting the technique had suffered structural failure, while 7 Mosquitos using standard evasion had been lost since January. On March 22nd, Stevenson authorized limited instruction in what was officially termed high-speed emergency descent procedures. The approval came with strict conditions. Training would be conducted above 10,000 feet to allow recovery altitude. Pilots would build up gradually starting at 420 miles per hour. Any sign of structural distress would ground the aircraft immediately for inspection. Perry became the unofficial instructor. He developed a methodical approach. First flights involved straight dives to 430 miles per hour. Second flights pushed to 450. Third flights reached 470 or higher. The psychological adaptation was harder than the physical technique. Squadron leader Adrian Warburton, one of the RAF's most experienced reconnaissance pilots, attempted his first training dive on April 2nd and pulled out at 435 miles per hour. His post-flight report was candid. "I believed intellectually that the aircraft could sustain the speed. I did not believe it emotionally until I'd done it." That distinction between knowing something was possible and trusting it was survivable defined the adaptation period. The engineering validation came in July 1945 when de Havilland's chief test pilot conducted systematic high-speed dive trials at Hatfield. The results astonished the design team. The Mosquito could safely exceed 500 miles per hour in a dive, nearly 100 miles per hour faster than published limitations. Senior aerodynamicist Ronald Bishop concluded that pilots had empirically discovered a performance envelope that theoretical calculations had completely missed. The wooden monocoque construction distributed loads in ways that conventional stress analysis couldn't predict. More remarkably, the highest time operational Mosquitoes showed no cumulative structural damage. The wooden spars hadn't fatigued the way metal structures did. Each dive stressed the wood to near its elastic limit, but when loads came off, the structure returned to its original shape without permanent deformation. Metal wings accumulated microscopic cracks with each high-G maneuver. Wood simply flexed and recovered. The power dive became operational legend, the technique that turned hunters into spectators, that made wood superior to metal, that proved pilot instinct could sometimes exceed engineering calculation. David Perry's desperate dive that March morning had discovered something the engineers never imagined, that the wooden Mosquito could outrun metal hunters not despite its construction, but because of it. And that discovery saved hundreds of lives in the skies over occupied Europe.